In this video, I want to answer the following question. Given a continuous function f defined on a closed interval AB, how can you find the absolute maximum and the absolute minimum? We're guaranteed by the extreme value theorem, if we have a continuous function on a closed interval like this, we're guaranteed that the maximum and minimum exist. But that doesn't tell us how to find them, so I'd like to demonstrate that now. So let's work on a problem. Find the absolute maximum and minimum of f of x equals x cubed minus 3x on the interval 0 to 2. Find the absolute maximum and the absolute minimum, the highest point and the lowest point of this function of x cubed minus 3x on the interval, the closed interval, 0 to 2. Let's go through the steps. Step 1, find all the critical points. That's all the places where the derivative equals 0 or doesn't exist. Well, this is a polynomial. It has a derivative everywhere. You know that that polynomials, their curves are nice and smooth everywhere. So the derivative exists everywhere. Let's go ahead and find the places where the derivative equals 0. So we'll take the derivative, f prime of x. That's going to be 3x squared minus 3. And we'll set this equal to 0. So 3x squared minus 3 equals 0. We can take that equation and divide both sides by 3. So x squared minus 1 equals 0. That factors as x plus 1, x minus 1 equals 0. So x either equals -1 or x equals 1. Step 2. Discard all the critical points which are outside your interval. You don't care what happens in this problem except between x equals 0 and x equals 2. You don't care what happens to the left of 0, and you don't care what happens to the right of 2. So discard all critical values outside the interval. Discard all the critical values outside the interval. So we are going to get rid of x equals -1. We don't need that. So we only have x equals 1. That's the only critical value left, the only critical point left. Step 3. Plug in the remaining critical points. This time we only have 1. Plus both endpoints into the original function. So we have one critical point, in this case, which is in the interval, and we have two endpoints. We're going to plug all three of them into the original function. So let me just put original, not into the derivative, into the original function, f of x equals x cubed minus 3x. So let's go ahead and do that. X, and then the y coordinate is the same as f of x, which is x cubed minus 3x. So we're going to plug the critical point in, which is x equals 1, and both endpoints. We're going to plug in 0 and 2. If we go ahead and plug 1 in, we get 1 cubed minus 3 times 1, that's 1 minus 3, that's negative 2. If we go ahead and plug 0 in, we get 0 cubed minus 3 times 0, that's 0. And if we plug 2 in, we get 2 cubed, or 8 minus 3 times 2, 8 minus 6, that's 2. Step 4, pick the biggest and the smallest. So between negative 2, 0, and 2, you can see the biggest value is right here, and the smallest value is at 1. Minus 2 is lower than 0 and 2. Let's go ahead and write a concluding statement. So f has an absolute maximum, I'm just going to write max, of the highest value, the highest y value is 2 at x equals 2. And f has an absolute minimum of negative 2 at x equals 1. So we have an absolute maximum at height 2 at x equals 2, and we have an absolute minimum of minus 2 at x equals 1. This problem is finished. We did exactly what we said we were going to do. But I do want to sketch a curve for you so you can sort of see what we did algebraically. So this curve looks something like this. At x equals 1, let's see, we're at height 2. At x equals 0, we're here. At x equals, no, I'm sorry. At x equals 1, we're at negative 2. At x equals 0, we're here. At x equals negative 1, we're at positive 2. And this thing crosses the x-axis again at about here and about here. We'll do more of this graphing later. We don't have to. If you couldn't do this in your head, don't worry about it right now. So the curve looks a lot like this. That's not quite as smooth as I would hope. I'm sure your picture looks better. It looks a lot like that. And at x equals 2, we're up at height 2 again. So we were concerned about the part of the curve between x equals 0 and x equals 2. We were concerned about the part of the curve that's between here and here, between these 2 points. That's the only part of the curve we were concerned with, because that's the x range we were given between x equals 0 and x equals 2. and we were asked to find the maximum and minimum value there. And we found the minimum value was at x equals 1. It just happened to be, in this particular example, at an integer value. It could have been anywhere. It could have been, at square root of 2 or something like that. It just happened to be at a whole number in this particular problem, but you can't always expect that. And we found the maximum at 2. That's the highest value that this curve takes in the interval between x equals 0 and x equals 2. And here's the lowest value that it takes. So that's what we found algebraically. You do not have to draw a picture to be able to do this problem, but I think it helps with the visualization.